So we're going to be looking at the biosphere and how it's broken down into its different biomes. The biosphere is the region of the planet where all life exists, and we refer to all that life as biota. Biota is just a collection of just the living things in the biosphere. The bacteria, the plants, the protista, the fungus, and the animals. They all make biota. And remember, bio means life. Now, Earth has four major connected systems. We have the biosphere, which is all the ecosystems together, the top level of organization. We have hydrosphere, right? Bio means life. What does hydro mean, guys? Water. Atmosphere, referring to the air, right? And then geo, which refers to earth, right? Earth, or you guys can think of it as rock. So that's all the soil. Okay? So if you look at these four spheres, they kind of work together with each other, right? To make up all of the interactions within the biosphere. Now, if you think about it, this Gaia, has anybody ever heard of this? This Gaia hypothesis? Is you can think of the planet like one giant living thing. You can think about how if you affect one thing, it really has a ripple effect that affects everything else. This concept of interconnectedness is important. So let's take the Yellowstone fires, okay, as an event. Okay, when fires happen in a place like in as an example, Yellowstone fires, how does that affect all of the four different spheres, right? The atmosphere, the hydrosphere, the geosphere, and the biosphere. Well, some of the things that it says here is that the ash in the air can lead to rainfall, and dry air evaporates and causes steam water. So what happens in the air affects what happens with the water. Right? Water erosion may lead to cloudy, muddy streams. And so this water erosion, right, will affect this life. Predators and prey may be forced to the same water area. So if the water gets dried up or affected by the fire, then everybody's drinking now at the same spot. You're putting food right next to the predators, and that'll affect it. Okay. Bird reseeding may not be effective in scorched topsoil. So if you have affected the land, it's going to affect the seeding of new life. So what happens to the soil affects what happens to the biosphere. Burned deep woods offer less winter cover for larger animals. So there the air is affecting the living things. Rain leads to erosion and affects the wind seeding. So you have a connection between the air and land here. So they're all interconnected by this one event. Okay, let's look at the climate. Climate is the prevailing weather of a region. A weather is the day-to-day, right? The long-term things. Weather is what's going on today. Climate is the weather over long periods of time. So you might look at the weather tomorrow and it's raining, and the day after it might be sunny. But if you look at the accumulation of all the weather patterns throughout a long period of time, let's say a year, that will give you the climate. So we measure our biomes based on the climate. And so you can look at that in terms of long term, yes?
Why sometimes, when it's about to rain, right?
Yeah.
And it's like half the sky is like super dark, and then the other skies that have the other half.
So the darker part is where you have dense cloud cover, which is a dense collection of moisture where the water vapor cools down and forms those water-rich clouds. So then, the light can't penetrate through that cover. It's going to look darker. And the part that's lighter, you don't have that type of water moisture that's condensed down into the cloud coverage, and the light will penetrate through. because water moisture is specific in specific regions based on what's beneath it and how the wind carries it. So where you have moisture going in the air and the wind can carry that moisture places, wherever it cools down, that's where clouds are going to form. And so you can see here, right, when you have heat evaporate the water, whether it's from a land lake or whether it's from ocean lake, that liquid, which is, cold, turns into gas, which is hot. But as you go higher and higher into the atmosphere, the temperature drops and causes the gas to turn back into liquid. And those droplets of water are clinging to particles in the sky, and that's what clouds are. And when the clouds get too heavy, right, because they can't cling on to that water moisture, then they'll drop as either snow, rain, sleet, things like that. And so an area's climate is a factor of all of these different types of things that will give you its climate. A microclimate is a climate of a small specific place within a larger area. So if you look at a region in a forest, you can look at the climate of the giant area of land, or you can look at a little watering hole or a little stream or at the top of a hill and talk about how that climate is different than other regions of that forest. And so if the climate's different there, you're probably going to find different organisms there, different biota. Now we have three main climate zones, right? We have a polar zone, and there's two of them, right? Right here, in the north and south. We have temperate zones where we live in both hemispheres. Oops, sorry. That's not a temperate zone. Here's the temperate zone. Temperate zones have fluctuations of seasons. Sometimes it's hot and dry. Sometimes it's cold and wet, right? Because of the tilt of the axis, because the Earth is tilted, these regions can be leaning towards the sun in certain parts of the year and leaning away from the sun in other parts of the year, and that's where you get seasons. Now, regions in the tropical zone, the tilt of the axis does not affect those regions as much, so the direct angle of sunlight that hits those regions doesn't really fluctuate that much throughout the year, so you have a pretty consistent temperature and climate and water levels and rain levels for the most part year-round. And so this uneven heating of the sun's light, right, as it's hitting at different angles, this uneven hitting of sun is going to get you these different climates. And so where you have more direct sunlight, okay, you're going to get it to be hotter. Where you have more of an angle, it's going to be colder. So there's two things that cause this to happen. Let's say that the Earth was not tilted and it was straight. Well, the fact that it's curved will give you different angles of sunlight. So less sunlight, less angles of that energy, less heat, it's going to change the temperature. But we also have the fact that the Earth tilts. It tilts like this. So when you're leaning forward, right, that's going to get a more direct hit of the sun. But when it wraps around to the other part of the orbit, that same region, because here's the sun, right? 6 months later, right? Same region. Check it out. It's on the backside. Now it's leaning away, leaning backwards from the sun. So it's going to have a different angle that it's going to hit. And obviously it spins around. It'll be right here, right, during the day. You're going to get a totally different angle of sun than when you're like this. What we need to understand about wind is where hot meets cold. Same thing with water. Currents is where hot meets cold. We need to understand that warm air rises, warm water rises, and cold air sinks, cold water sinks. And so that is due to the density. Okay? Warm air and warm water is less dense. So if you have a cup of water, if you have stuff that's more dense on the bottom and less dense, it'll be on the top. Same thing with air. And where the more dense and the less dense meet, right, there's a mixing. And that causes wind and currents. Now, different land masses on land will also shape their climate, whereas regions within the coast tend to have smaller changes in temperature because the ocean that it's right next to helps moderate the temperature. So you'll see places like where we live, we don't see dramatic changes in our temperature because we're right next to the ocean. Now, mountains, on the other hand, have a very dramatic effect on what happens in the climate. This is a mountain, and on what happens is you'll see here's the ocean right here. If I have a mountain, okay, this part of the mountain is going to have a much different climate than this part of the mountain. And so they have a large effect on what happens to the amount of rain. And the part of the mountain that gets most of the rain, because the cloud, what happens is you have the ocean here, you have evaporation, you have condensation, and the mountain blocks this from going to the other side. And so the rain falls on this side and not on this side. And what you get are these two completely different climates. So many organisms have to adapt to that specific climate, obviously, like this winter fox.
It looks like a pillow.
Now, if you have a temperate fox, if they were what type of zone do you think this guy lives in? Polar, temperate, or tropical? Probably polar. Yeah. Now, if the fox lived in a temperate zone, it's going to be much darker.